Hi, so this is the what is it? EJC tutorial on hypothesis testing, question 6. So let's read the question. You have a random sample of 90 batteries. You're testing it for its standby time. Take note there's two parts of the question. One is standby time, one is talk time. Okay, so for standby time, the time is of the standby time of the battery is measured in hours, and we obtain from that sample of 90 a sample mean and a sample standard deviation to be 33.787 hours as well as 12.035 hours respectively. Now we want to test at a 100 alpha percent 2% significance level whether the mean standby time is less than 36.0. So less just tells you it's a one-tail test already. Over here, the solution, you start off by calculating the unbiased estimate of the population variance. Why did we do that? Because they didn't give us the population variance. So we have to use the next best thing, which is the unbiased estimate, S squared. And using the formula, we can get this guy. Okay, then after that, we let X hours denote the standby time of a randomly chosen battery. Got a H naught, got a H1. H naught is the 36.0 value that we are testing, given by the question. Then this less than 36.0 is also requested by the question. Okay, good. So this is our not necessary, but you can put it there just to be more precise. Okay, maybe the 2% level is important, but the one tail is not. You don't need to mention it because it's obvious from here. Yeah, just mention your alpha 2% level of significance or 100 alpha percent. Then under H naught X bar, the sample mean follows normal distribution. Mean this guy variance not sigma square anymore but S square over N. Then approximately by CLT. Then you can use the calculator z-test, key in the values, and then you will get your p-value 0.041395. Then since this value, they rounded off to 3SF, is more than this 2% level of significance, which is the 0.02, then H naught is actually not rejected. There's a typo with the solution. Is not rejected at another two typos at 2% level of significance. Hence, there is insufficient at the 2% level of significance to show that the mean standby time is less than 36.0. Okay, so yeah, just to clarify over here, I wrote down when you reject, when you don't reject H naught. Right, reject H naught if the p-value is less than or equals to alpha. Then don't reject H naught if the p-value is more than alpha. Okay, so that was the using p-value method, but let's interpret it in terms of the test statistic as well. The critical value or critical region approach, rejection region. So what we want to do is to mention the test statistic, z equals to this guy, the standardization of the sample mean, x bar. You start off with x bar, you minus away its mean, then take the square root of its variance. Okay, then this will follow normal 0, 1. Now, since it's normal 0, 1 means 0, it means that there must be a bell curve that's symmetrical about 0, x equals 0. And we can calculate the, what do you call this, the x coordinate, not really, the quantile value associated with each of the probability values. In this case, alpha is what? Alpha is 2%, so we can just use inverse norm, area is 0.02, then mu is 0, sigma is 1 because it's n01. Then we are able to obtain the negative 2.0537 as our critical value. So what does it mean about our critical region or rejection region? It means that we have to reject the null hypothesis if we have a value of the test statistic to be within this region, z less than negative, z less than negative 2.0537. So now we try to calculate the next value after the critical value. This is the z critical, by the way. Then now we try to calculate the test statistic z value. How do we get that value? We use the formula here, right? And then we substitute in with the 33.787 mean sample mean that was given to us. Alright, substituting it in, and we will be able to obtain this negative 1.734. Actually, this negative 1.734 can also be obtained when you're doing the z-test along with the p-value, or one of the information given by the GC. You can also calculate this negative 1.734. So what we realize is that this guy is outside of the critical rejection region. This arrow here, it's outside, right? So that just means that we have to not reject H naught. can. So yeah. Okay, then now that we have seen the critical seen the critical region approach, we have to link this graph to in terms of the critical region, we have to link it back to the p-value comparison with the alpha. What does this 0.0414 more than 0.02 mean graphically? It actually means that the pink area is bigger than the mud green area. Okay, so the 0.0414 is the pink color one. Let me just label 0.0414 roughly 3SF. So this pink color area is referring to your p-value. Okay, then this mud green, don't know what green area is your alpha. Then if your p-value is more than alpha, you do not reject H0, right? You do not reject H0. Okay, so now that you know this idea, where there are actual numbers involved, we go on to the more complicated question where there are no more numbers involved. Okay, so the second type of question, they tell you same battery, but then now we measure the talk time. Okay, so the yeah, so what does it mean? It means that actually not sure if I interpreted this wrongly, but what we realize is that there is a totally different okay, so there's a totally unrelated test. Okay, it's not entirely unrelated, it's the same battery but we are doing a different hypothesis test this time on the talk time. We want to check whether it is less than 5 hours or not. So that's when we should, to be formal, we should let x hours denote the talk time this time of a randomly chosen battery. Then we can introduce a null hypothesis, alternative hypothesis. Then mu is equal to 5 or mu less than 5, right? Because that's what they're testing, less than 5 hours. So we are also told that there is, in a test at 5% significance level, there is significant evidence that the population mean talk time is less than 5 hours, which means that significant evidence for us to accept H1, which also means that we have decided to reject H0 at the 5% significance level. So rejecting H0 at 5% significance level. What does it mean now? If you recall, reject means what? P-value is less than or equals to the alpha. So in terms of area, I mean, we are not given enough information to get the x bar and the z, but we know that they exist, and then as a result, we have the corresponding bell curve with mean 0 and variance 1. But even though we don't know this, as long as we know the conclusion, we know how the graph will look. So let's just go over to the graph. So again, just in case I'm wrong, let me just refer to this. Reject H0. When does it happen? If the p-value is less than or equals to alpha, right? Okay, let me write it down. Reject H0 means p-value less than or equals to your alpha. Alright, so since we know this means that we have to translate it into a graph. So I decided to use red color this time to represent the, oh wait, hold on. Sorry. Let me edit my graph a little bit. Okay, try again. Yep. Pretend you didn't see that. So restart. So this is the bell curve. We want to make sure that our p-value is now less than or equal to alpha. In this case, it is your 0.05. So let's just use the same color, So maybe okay, let's just color in the graph. So we want p-value to be less than or equals to the 0.05. So maybe we first start off with a 0.05. Where would that be? It would be this part over here. Okay, this is 0.05. that is your alpha, 100 alpha percent significance level. 100 alpha percent significance level. 100 times 0.05 divided by 100 is 0.05. 100 alpha percent level of significance. Okay, so that is the green color area, but then we want p-value to be less than equal, so it means this pink color area over here, right? This part will be your p-value. Okay, can? Good. So let's just denote for this scenario. Let the p-value be denoted by the p1. Okay, so we can form an inequality just to be extra clear. This is small p. Let me write it nicely. Small p, p1. So that means that we know that p1 must be, the pink color area must be less than 0.05. Right? Less than 0.05. Good. So call this inequality 1. So moving on, we now want to consider the scenario where there is no, we change the alpha, okay, to 0.10 this time. Okay, previously it was 5%, 0.05, now we change to 10%. Will we still get the same conclusion? So what we need to know is that all this data in these question marks here, they still are the same. It's just that we change the alpha. It's just that we change the alpha, which means that our green area here will change to a different kind of green. The first scenario, this is part A. We change from 5% to 10% significance level. In terms of a graph, how does it look? It just means that our p-value here still stays the same, but then our green area here, it changes, increases. Have an additional portion here. Why? Because now this time the new green area, updated one, the total area is now 0.10, 10%. P-value, the pink color area, stay the same, the P1. Okay, maybe I should put comma P1, stay the same. Which means that P1 now is, originally we already know that, sorry, let me try again. 0.05 is of course more than 0.10. That's just truth. And then we know from that statement 1, from inequality 1, that P1 is less than 0.05. Right, the pink color area is less than the original green area. So what does it mean? It means that our P1 will then be less than 0.05, which is less than 0.10, and in other words, P1 is less than 0.10. I think that's very obvious from the graph. Our p-value, it does not change. We're still doing our left tail test. It will be less than the updated green area, which is 10%, because 10% is bigger than 5%. If P1 was originally already smaller than 5%, 5% is in turn smaller than 10%, so therefore P1 will be smaller than 10%, which also means that since our p-value is less than the alpha 10% level of significance, we conclude that we still confirm need to reject H0. So therefore the answer is necessarily true. Necessarily true. Still reject H0. Okay, H0. Yeah, we still need to reject H0. Okay, okay. So yeah, why did I talk about reject H0? Is because the question, they mentioned that there is significant evidence at 10% that the population mean talk time is less than 35. In other words, we want to confirm that the less than 5 hours is true. The H1, we want to accept H1, which also means we want to reject H0. Okay, maybe I should write that down. This guy is just saying reject H0. Same thing for part B. Same thing for part B. We also want to check that we can reject H naught. However, this time they changed the word. Instead of saying less than, they said not. Instead of 10%, they changed to 5%. Okay, so what does it mean? So what changes? When they change from not, from less than to not, it just means that we now, for part B, we have to change the hypothesis testing. So at first it was H naught mu equals 5. Sorry, how can H naught have an inequality? And then H1 will now be mu not equals to 5. We want to check whether it will be rejected at how many percent? Rejected at the 5% level of significance? Question mark? We don't know yet. Let's explore. Then we will see. Okay, so let's see. This time, right, because it is 5% level of significance, what does it mean for a two-tailed test? It means that we actually need to split into two halves. 5% is what? 0.05. We actually now need to split into two halves. 0.05 over 2 for left side and the right side. So what does it mean? It means that we will have the same graph. Yeah, the p-value definitely will still stay the same because all of our previous information, all of our previous data, or the mean, the variance, sigma square, s square, and all that stays the same. The only thing that changes in our scenario is the alpha that we are looking at, and the two-tail. This doesn't affect our test statistic value, and hence our p-value. So the p1 keeps on staying the same. The only thing that changes now is we are doing two-tail tests, which means that we have to split our level of significance 5% up into two parts, 2.5%, 2.5%, which is really just 0.025 on each side, on the left and on the right. Okay, so let's just draw a picture for, I don't know whether it's true, but let's just draw a picture for the case where we do reject the H naught. In other words, our p-value is less than our what do you call that? Our p-value is less than our alpha. But in this case, it's a two-tailed test, so that means that we actually would have a different p this time when we try to calculate. So we can let p2 be that guy. Let p2 be the p-value of this two-tailed test. Okay, how do you get that value? If we are using a GC, we would be writing down this fella here, and then after that we go and use a z-test, and then we calculate the p-value. But graphically for two-tail, p-value would be now two parts here. The right half by symmetry, it will still be p1, but the sum of these two, if you add them together, this will be p2, which is 2 times p1. Okay, the sum of the pink color area here and the pink color area there, that's your total p-value p2 for this two-tailed test. Okay, that's interesting. Then, yeah, what was I trying to draw? I was trying to draw a 2.5% on each side. So let's just assume it's a scenario where we do reject H naught. So we have to have this guy. This on the left side is 2.5%. On the right side and on the left side also 2.5%. Then what you realize is that you require, in order for us to reject H naught for sure, we would need our P1 to be less than 2.5%, 0.025. And how would that be confirmed, right? Okay, maybe I should start with the P2 first. In order for us to reject H naught, P2 must be less than the 5% is required. I never say it is confirmed less than 0.05. I just say this is the requirement. But what do we know about P2? P2 is actually 2P1. So we can substitute in. i.e. this guy is required. And i.e. P1 must be less than 0.025. which is also obvious from the picture lah, huh? This guy, the pink color area P1 must be less than the 2.5%, 0.025. How do we know that for sure? Do we know that for sure? No, we cannot tell that. What are the things that we do know? What are the things that we do know? We know that inequality 1, this is definitely true, right? Okay, so let's just copy down the true statement. So many is required, but nothing true. So the only thing that we do know for sure is P1 less than 0.05. So, okay, then let's compare our requirement here, it's quite star, versus what we do know to be true. What can we conclude? If this is what is required in order for us to reject H0. Inequality 1 is what we do know from the previous part, from the given statement. What was the given statement? That we reject H0 at the 5% significance level when we were doing this kind of test, one-tail test, comparing comparing mu less than 5. And then we reach this true conclusion that P1 less than 0.05. So now we have to compare this requirement, the star, versus this equation 1, the truth. This is truth. This is true. A true statement. Then let's take a look. P1 less than 0.05. Oh, of course, it's a probability value, right? So it must be bigger than 0. Okay. Then let's just draw a number line just to be extra clear. Here's 0, here's 0.025, here's 0.05. We know this is true, which means we can draw inequality 0 until 0.05. So P1 here can be anywhere in between. Won't be too. Let's not bother ourselves with the equality case or not. Doesn't really matter. Then how about the requirement? The requirement was P1. You need it to be less than 0.025, which means, of course, it also has to be more than 0 lah. Probability cannot be negative. So that just means we need our requirement. Maybe if I color code it in red, is this guy. Right? 0 less than P1 less than 0.025. Does the black imply the red? We have to go in this direction. Okay. From the black imply the red. The answer is no. Sometimes true, but other times not. Right? Because here, if P1 less than 0.05, it could be anywhere in between 0 to 0.025, or it could be more than 0.025 but less than 0.05. Anywhere is possible. Right? Let's not care about the boundary case where it's 0.025. So what this really means is that we cannot confirm. Right? We cannot confirm. So therefore, the answer to, sorry, is it part B or part 2? The answer to this part B here is that it is neither necessarily true nor false. Sometimes it's true, sometimes it's false. We cannot have a definite answer, unlike our part A. Part A is can because of the chain of inequalities. Okay. Part A is because we need it to be, we know that we are always less than 5%, 0.05, and our requirement is more loose. We just need it, we just need the P1 to be less than 0.10. If we satisfy the strict condition, of course we satisfy the loose condition. So that's why it is necessarily true. Okay, if we relax it to 10%, it is confirmed still it will still be rejecting H0. Right? If we manage to reject H0 when it is so strict at 5%, we are also able to reject H0 at the more relaxed 10%. However, over here, when you change it to two-tail test and you try to check 5%, you realize that you're trying to compare with a 2.5% on the left, which is not necessarily true. Sometimes it will be true if your P1 less than 0.05 was somehow over here, maybe it was a 0.01, then it will be possible that it satisfies the rate inequality, the requirement as well. But other times it could be something bigger than 0.025, less than 0.05, which means that it doesn't satisfy the less than 0.025 requirement. Okay, so this is neither necessarily true nor false.